Welcome to Python Variables chapter. In this chapter, we are going to learn about what are variables, what are different types of variables, data types, and different operators in Python, number systems, conversion tables, and type conversions. So let us begin here. What are variables? Variables are the containers that are used to store data in a program. So it can hold values like numbers or text or even address of some other variable. So you can use variables that can be used to save data and reuse this data in the later purposes. So feature of variables in Python says that you don't have to declare the data type of a variable when you are creating a new variable. So Python internally figures out what is the type of the variables depending upon the value it has been assigned. You can simply create a variable with an is equal to symbol, like say x equals to 10. So here x is a variable created with the value 10. You can keep on changing value of the x variable along with the type as well as its value. So in the next line, if you say x equals to in double quotes India, so that is also a valid statement. So here on the left side you can see some examples. Let's say name equals to Alice. So if you are putting the value as in string type, you have to give double quotes. If you are giving a number, age equals to 25, so no double quotes are needed. If you are saying floating point value, say height equals to 5.8, the decimal values can be stored. And if you are creating a Boolean type of variable, say is student equals to true, so T capital true, this is going to store 1 in is student variable. So these are some variables that can be created. There are three different types of variables: global variables, local variables, and constants by convention. So let us understand what are these types of variable. Global variables are the variables created outside of all the functions, like in the main scope. Here, the variable are accessed anywhere in the program, even inside and outside the functions. We will understand about functions in upcoming chapters, but for now, to understand the scope or accessibility of variable, we must know global variables are accessible in entire program. So they are useful for storing values that needs to be shared across multiple functions. So if you have some common value which is to be shared across functions, you can keep that type of a value in a global variable. Then comes the local variable. Local variables are the variables that are declared inside the function. So it says that this variable is available only within the function. You cannot access variable outside the function. As they are created inside the function, as soon as the function definition terminates, the variables are also gone out of the scope and they are destroyed when the function ends. And third says constants or by conventions. Like constants are variables that should not be changed. Okay, like for example, if I am creating a value of pi, the standard value of pi is say 3.14, the value must not be changed, so it should be kept constant. So Python does not have true constants, but by convention we use uppercase letter for constant names. So you can create constant variables by uppercase letters. Say here in example, if you see pi equals to 3.14, so this is a constant variable created with value 3.14. This helps the programmers understand that the value is meant to stay same. So the values must not be changed for these constant type of variables. So there are three types of variables: global, whose accessibility and scope of variable is for entire program; local variables, which are available only within the function; and constants. To create a constant variable, you need to keep the variable name in the capital letter and you can just assign a value to it, so the value will not be changed in the program. So on the right side, if you see a small example for the global variable, say name equal to Alice. So here a normal global variable is created which is accessible throughout the program. To create constant, as I said previously, pi in the capital letters equals to 3.14, and I'm creating a greet function by using this def greet statement, message hello plus name. So here Message is a string created with hello plus name, which is accessible globally from variable name which was created here. Okay, and I'm printing a message, so I will get an output hello Alice. Then this is the main entry point of the program, greet. Now I am starting the execution of the program directly by calling a function, executing it, coming back and print pi. It is going to say 3.14. I know this explanation for greet function would be a little difficult for now, but we are going to dig in deep about what are functions and how they are used, invoked, called, defined in upcoming chapters. For now, let us stick to three different types of variables: global variables, local variables, and constants. Moving ahead, we must know what are different types of data types in Python. If you are going to store numerical value like integer numbers, you have int data type. If you want to store decimal values, you have float data type. If the value is in the form of text like in double quotes, then it is considered as str, which is a string data type. If the values hold are only true or false, then it is of a bool data type, so it can hold only 0 or 1 value. Then comes the collective data types, like if you are having multiple values stored together, then it is list. Now the difference between list and others is list can be created in the pair of square brackets. They are ordered and they are mutable. Now mutable means you can change the value of the contents. Okay, the values of this contents can be changed if the type is of list data type. Tuple is another type of a collective data type which says that it is again ordered but immutable, means you cannot change the values of the tuple once it is created. So to differentiate between list and tuple, the type of brackets that are used. So square bracket indicates it's a list and round bracket indicates it's a tuple. We have one more data type, dictionary. Dict is the data type name for it. So dict says that you can keep a value and keep pair in the dictionary, but enclosed in the pair of curly brackets. So these keys and values are paired together. You can keep comma separated multiple keys and values enclosed in one curly bracket. So that creates a dictionary, dict type of an object. And set is another data type which again is similar to dict, but it doesn't have key value pair and it is unordered, means there's no indexing to this collection, so they are randomly accessed from this set. So set can be created with a pair of curly brackets. So these are main data types provided by Python. We are going to learn about these collection of different types of values like say list, tuples, dict and sets in upcoming chapters. So moving ahead, what are different types of operators available in Python? Firstly, we will see arithmetic operators. Plus is used for addition, subtraction, multiplication, division and its respective symbols. Percent sign is used as a modulus. 2 asterisk is used as exponentiation and 2 forward slashes used for floor division. So let us see directly with the example here. Very simple ones like say 2 plus 3 says 5, 5 minus 2 says 3, 3 into 4 says 12 and 10 by 2 says 5. So these are the basic mathematical operations like addition, subtraction, multiplication and division. With modulus we get the remainder of the division. Say if I am dividing 10 by 3, I am going to get the remainder 1. Now if I put a decimal point and then continue with the division, here in this case it is not allowed because modulus says that I will stop as soon as the requirement of this decimal arises. Okay, so I'm getting the value 1, which is the remainder of the division. Now next one is exponentiation, which says that 2 into 3, which says that 2 power 3 and I'm getting the value 8. Say 2 into 2 into 2. So I'm getting the value 8. Vice versa, if I say 3 exponentiation 2, the value will be different. Say 3 into 3, which is 9. Then comes the floor division. Say 7 by 2. Here I'm getting the quotient of the division. Just like the modulus, it will keep on dividing until the raising of decimal is not found. As soon as decimal is to be put in the division to complete it, it will stop the division and give quotient as its result. So these are important arithmetic operators provided in Python. Now next type of operator is relational operator. Relational operators are used for comparison. Like if we have two values, I can compare the values with different symbols. The relational operator returns the values always in the Boolean type, let's say true or false. So some of the symbols are greater than, less than, equal to, not equal to, greater than equal to, and less than equal to. So now here if I say 4 greater than 2, it is going to return me value true. 4 less than 2, false. 4 equal to 4, it will give me true result. 4 not equals to 5, yes, these two numbers are different, so it is giving me true result. 5 greater than equal to 5, yes, it is true because it is checking the upper limit along with the next number. So 5 greater than equals to 5, both the numbers is either greater or equal, so this is 5 greater than equals to 5, true. Now in this case 3 less than equals to 4, so this is also true. And if I would have written 4 less than equal to 4, again it would have given me true. So these are important relational operators in Python. Another type of operator is logical operator. There are three logical operators, say AND, OR and NOT. These operators are used to combine multiple situations or conditions and generate the common result. So AND operator will return if both the conditions are true. OR operator will return true if any one of the state is true. And NOT operator will give the opposite of it, say not true, so it will return false. So these are three standard logical operators widely used in combining the conditions in if statements or elif condition. We will understand them in detail about these operators and its implementation in further chapters. Then comes the identity operator. Identity operator checks whether the value is same with the next comparison value. Okay, so for example I'm saying is, so here is it the same object, so it is going to return me true. So if I'm saying x is y, if the value of x and value of y is same, it is going to return me true value. Okay, and is not says different objects, say is x is not y. Let's say I'm saying value of x is 3 and value of x is 4, so x is not y, 3 is not 4, yes, it is going to return me true. But if both the values are same, say x and y both are holding same value 3, then x is not y will return false. No, they both are same, so it is going to return me false in that state. Okay, so another type of operator is assignment operator. Assignment operator is used to assign a value to a variable. Let's say equals to sign, here x equals to 5, so 5 value is assigned to the variable 5. I can also assign multiple arithmetic operators along with the equal to sign, like say plus equals to, minus equals to, multiply equals to, divide equals to. All those arithmetic operators can be clubbed together with assignment operator, and firstly it will perform the arithmetical operation and then it will assign the value to it. So let us take a simple example, x plus equals to 3. Now considering the value of x equals to 5 and then I am saying x plus equals to 3. This says that x equals to, the expression is ideally resolved as x equals to x plus 3. So the value of x was 5, so 5 plus 3 which is 8, and I am getting the result as 8. Similarly, if I am using minus equals to, So in this case, x equals to x minus 1. So here 8 minus 1 value will be 7. So you can use different arithmetic operators along with the assignment operator. Another type of operator is membership operator. Now membership operators are mainly used to check whether the given value is existing in the given set of collection. As we had seen in the previous slides, like list, tuples, dictionary, sets, these all are collective data types. So it can hold multiple values. So membership operator can check whether that value is existing in that given collection or not. So the keyword is in and not in. There's a space between not and in. Okay. So in will return true if the value is existing in the collection. Say example 1, in the collection of list 1, 2, 3. So here it is returning me true. Yes, 1 is existing in this collection. So I'm returning true. And another example, say 4, not in 1, 2. Now I have another collection 1 and 2 and I'm checking whether value 4 is not in the collection. Yes, it is not there in the collection. So it is returning me value true. You can use in and not in to check whether the value is available in the given collection. Now let us know about number systems. Number systems are nothing but ways to represent numbers using different bases. Python supports multiple number systems which are commonly used in programming. So let us know about them in detail here. First is decimal number system. The decimal number system consists of base value as 10 to let it identify that this belongs to the decimal part of the numbers. So it is most commonly used number system by humans. It consists of the digits from 0 to 9 and each digit's place value is power of 10. So let us write an example, say 7, 41 and in brackets I will write here with the subscript as 10 which indicates that this is a decimal number system. Another number system is binary which has base value 2. It is internally used by computers. Computer is a digital device or an electronic device which consists of only two numbers like zeros and ones and identifies the values based on its presence. So only two digits are used, zeros and 1, and its power value is 2. So let us take an example. In brackets we can write say 0, 1, 1, 0 and the bracket close and I write the base value 2. So this says that this is a binary number. Another number system is octal. Octal number system has base 8 and consists of digits from 0 to 7. These octal number systems are used in programming for file permissions and memory addressing. So let us take an example, say 7, 4, 1 again, but the subscript number is 8. So the example of decimal and octal remains same, but here we understand with the base number, if it is 10 then it is decimal and if it is 8 then it is an octal number system. And fourth number system is hexadecimal number system having the base as 16 which consists of digits from 0 to 9 and letters A to F, where A represents the number 10, B represents 11 and so on, and F represents 15. So A to F makes up 6 letters and 0 to 9 are 10 digits, hence it is called as hexadecimal like 16 and it takes the power of 16. These number systems are majorly used for color codes, memory addresses and machine level programming. So let us write an example of hexadecimal number system, say A 7 4. Now here in the brackets I will write 16 which indicates that this is the hexadecimal number system. So the base numbers are really important for the system to identify which type of number system we are talking about, whether it is decimal, binary, octal or hexadecimal. Now Let us see about the conversion table and the functions which are available in Python, which allows us to convert the number into any of the number system. So let us take an example. We have decimal as a variable name with 31 as its value. I want to print the binary, octal or hexadecimal value of this decimal variable. So I have built-in function bin, oct and hex respectively to convert the decimal value and print its respective value. So the example says here, print bin decimal. So value of decimal 31 will be replaced here with the variable name and converting it into bin. So bin of decimal will give me the binary number of 31 on the output screen. Likewise, if I write print oct decimal, so it will take the decimal value 31, convert it into octal through this oct built-in function, which is 0037. Now here 0b, 0o and 0x, these are the prefixes mentioned here which identifies what type of number system we are representing here. So hex function will convert the same value into hexadecimal and write says 0x1f. Following table also shows different examples of converting the decimal into binary using bin function, oct for octal and hex for hexadecimal. Likewise, the decimal number 12 can be converted using bin into binary, using oct function into octal and hex function into hexadecimal. So these are built-in function, we just have to pass on the value to it and it will simply convert the number from decimal to its respective number system. Now moving ahead, let us find ASCII value. Now first of all, what are ASCII values? ASCII stands for American Standard Code for Information Interchange. Here it is a system that assigns a numeric value to each and every character like letters, digits, symbols, special symbols, even spaces. All these things have a numeric equivalent value mentioned in this ASCII table. So for example, capital A has ASCII value 65, small letter a has ASCII value 97, 0 has ASCII value 48. So these values are predetermined in this ASCII table. Now we can use ASCII table for different purposes, like computer stores and processes the characters as numbers. So if we are putting character as an input to the computer, it will firstly convert into ASCII and then convert it into binary form. ASCII helps to convert the characters and their numeric representation. It is useful in tasks like encryption, sorting and character comparisons. So we have two basic built-in functions, ORD and CHR. So ORD function returns the ASCII value for the character that we are going to pass to it. So the example says print ORD of A. Now here A value must be passed in double quotes because it is a character and it is going to give me an output 65, the equivalent numeric value of it from that ASCII table. Likewise, if I use CHR function, it is going to work as a reversal, like give a number to it and it will return the respective character from the table. So for example, if I say print CHR of 65, it is going to give me the output letter A. So ORD and CHR are functions used to work with ASCII values. I hope these are pretty simple to directly use and check the output. Now next slide says type conversion. Type conversion means we want to change the data type of a value. So for example, if I want to convert a number which is already stored as string and convert it into an integer value. So conversions are basically needed when we want to work on particular data type. For example, let's say we have age as a value. Say age of a person is 16 and I want to predict his value of age after 10 years. So if I directly say input, it is going to take it as a string. So A is holding 16 as string. But now if I want to make some arithmetic calculations on this value, I'll have to convert it into string. I will have to convert it into integer. So Python provides type conversion method. There are two types of conversion, implicit and explicit. Implicit conversion is done automatically by Python internally. It happens when Python converts one data type to another during operations. Whereas explicit conversion is called as typecasting, where programmer is manually converting the data type. So let us see an example here. Implicit typecasting: x equals to 10 holding an integer value, y equals to 5.5 holding float value, and I say z equals to x plus y. Then here z becomes float, automatically adds 15.5 this value and stores it into the variable z. And with explicit typecasting, let us say I have a equals to 100, but it is in double quote, so it is string. Now if I say b equals to int of a, so I am converting string to integer. If I say c equals to float of b, it is converting integer to float. Now here b is an integer which is taken as parameter for this float function. And likewise, if I say d equal to str of c, here float is converted into string form. So these are int, float, str, these are built-in function available to convert the typecasting into an explicit manner. So I hope you understood this typecasting and type conversions of both the methods like implicit and explicit. We will see in the next video about different programs that we have covered so far in this lecture session. Till then, keep practicing. Do like, share and subscribe to my channel for more updates. Thank you so much.